Hi, how are you doing? Pill speaking here. Quasar Training Part 9, updated version 2020. In this part, I wanted to speak about configuration restrictions. So speaking of configuration, which we did in previous parts, we learned that there is data which is attached to the configuration files. So configuration files which essentially describe instances of Quasar objects that are gonna live in the OPC-UA address space, but also in device logic of a Quasar-based OPC-UA service. But the data which is attached, the additional data, so the config entries or the data which is attached to cache variables which are initialized by configuration, is the data that end users or system administrators or other people deploying your OPC-UA service in production will create. And therefore, the data should be considered like any other input data, which means it might be potentially invalid, out of range, it might be sabotaged, or any other possibility may hold, which means in a high reliability computer systems, you should perform validation of data. Okay, so that's why we have configuration restrictions. And what they improve is they improve maintaining coherency of configuration of servers, because the XML files that are the schema for your config files are aware of what's considered valid or not. So the config file that we've been playing with, so that was where we've been adding instances and also calculated variables. They have a schema file which is generated by Quasar. It follows the design, and we're speaking here on how to put the most information that can be that can help maintaining those configuration XML files in proper order. So part of this help, they also standardize the data model. It's because the XSD is a standardized language in which you can express certain restrictions, and also they simplify validation because you don't have to do in your code the checks yourself, or at least you minimize the number of checks you have to do yourself because the XML loader can do this for you basing on the information which is in the XSD schema. So as I remarked, the configuration restrictions are mostly achieved by XSD schema, which accompanies the config files. There are though few situations in which the usage of XML was quite difficult or impractical, and those are done by Quasar's configuration loader, but still the same rule holds that the conditions for the checks are based on the information which you place in the design. Let's have a look at our OPC-UA server project. It might be even easier to refer to the design visualization here. And what we see so far, we had one config entry. We had the refresh rate, which I actually don't remember if it was... where was it? The refresh rate? I think it was here, right? So there was a cache variable called refresh rate, which was also coming from configuration. So this would be also in the XSD for the configuration XML. So I'd like to demonstrate the type of configuration restrictions that you can attach to the data, such as, for instance, identifier is in a proper format, and maybe I add a bit more, so to demonstrate a few different cases, or maybe I just go one by one. So to illustrate the types of configuration restrictions, we have a number of types. So practically speaking, now speaking in terms of Quasar design, many of them, or most of them actually, we attach directly per given config entry, like this one, or per cache variable that propagates into the configuration. Okay, so let's look at the identifier. and I think it was the config entry called this one, called identifier. And now, as we can see, this content model allows us to add the XML element called config restriction, which I'd like to do right now. This one, okay, and it accepts possibly all of restriction by pattern, restriction by enumeration, and restriction by bound. Now, when we look at identifier, which, as you remember, we chose to be kind of like integer on the identifier of a given motor, because we assume that the controller can have a number of different motors, right? Up to, I think, 4 we chose. Then this identifier is simply the number on the bus that connects the controller with the motors, or however this is organized, doesn't really matter. But we know that the controller has up to 4 motors, and we have to identify our motor in the controller. So this is the identifier. So since we said that controller accepts up to or controls up to 4 motors, this identifier, well, logically, or the most obvious choice for at least a software engineer would be that the number is somewhere in between 0 to 3, or at least if you have a background in languages which enumerate starting from 0. So I would add this restriction here, okay? So adding restriction by bounds, okay? It makes a lot of sense for an integer number. And I would say that minimum inclusive is 0, and the maximum inclusive is 3. Okay, that gives us 4 numbers. Of course, you can also prefer to do this like minimum exclusive and maximum exclusive. It's up to your taste. This is what I prefer most. So now, if we rebuild our server. So far we had the situation that this identifier was 1, and that clearly is well in limits that we've defined to be from 0 to 3. But now let's imagine that somebody, or for whatever reason, this XML attribute that we have in the XML config was defined as 5. And let's try to run the server now. And it does not start. And you can clearly say that the place to blame is your config, and the value 5 must be less than or equal to max inclusive facet, blah, blah. So this is all the XML validity check. And if you are curious to understand, so the error is of course printed by Quasar, but in fact, if you dig a bit, and this might be interesting to you, is you will actually learn that there is a XSD, configuration XSD file, which was generated by Quasar for you, and there you find somewhere, you find a complex type for motor. This is that part. And there you find that there is a identifier, and your restriction was propagated into the XSD restriction. Okay, which means you can also use other tools like XML-lint to validate your config file, and it will tell you that it does not validate, which means you're using the standardized mechanism, which helps to integrate Quasar in a bigger software ecosystem. All right, so as we know, this is the first mechanism that we can think of. Then if you look at other possible restrictions that we find here, we find restriction by pattern, restriction by enumeration. So let's try another one. And we had somewhere a cache variable that is initialized by configuration, which means it propagates into XML schema. And we had a refresh rate here. And then let's assume that we'd like to place a restriction on the refresh rate. Of course, this looks like another integer, but this time I'd like to have it coming from a discrete set of values. So now I have another config restriction. I add a child to be defined by enumeration, and I add all possible values that my restriction should have. Which is, for instance, well, if it's a refresh rate in hertz, let's say, it could be, let's say, 1000, or maybe, just to keep this example concise, I would only allow two possible values, maybe 2000. Okay, and now let's try to start the server. And what we can see is, voila, some value is not in enumeration. And of course, this is expected. So we can either fix it here. Well, we have to fix it in the config, but the additional advantage is probably obvious to you that now refresh rate, Eclipse can actually load the file, and it knows that it could be either 1000 or it can be 2000. Okay, so Eclipse follows the schema. So I say 1000 and 2000, and voila, that works fine. All right, so let's now have a look at the third possible restriction. So so far we looked at I think restriction by bounds and restriction by enumeration, and the third one is restriction by pattern. And for this one, I'd like to add a new config entry at the level of controller to help me out with this example. And in this for this situation, I'd like this to be a string config entry. For a small background, I thought a controller is kind of connected to your OPC-UA server, like the OPC-UA server somehow communicates with the controller. There's, of course, a thousand of possible ways how something in the control system can be connected to your OPC-UA server. Just for simplicity, I assumed it's on USB. Okay? Not that I like USB, actually, I don't really like USB for control systems, but it's something that everybody understands. So that's why I'm picking it as an educational example. So I will add a config entry now to the controller, which will be called address, and the data type will be string. And let's assume that in my operating system, let's say it's Linux, for instance, USB interfaces have some operating system names, like the port names or whatever way you consider them, and that could be like USB 1, USB 2, USB 3 or something. It's just an example. It doesn't really have to be real naming. It's just an example. So I added my config entry called address, and now I'd like to restrict it to a pattern. So I'm adding a config restriction here, and then I'm adding a restriction by pattern, and I'm adding the pattern which I think matches what my operating system will like, which would be like USB, and then my regular expression is to have at least one digit, and by digit we understand a decimal digit. Okay, so one or more digits. So something like USB 1 or USB 2 or USB 25 should be fine, but anything else should not really pass this restriction. For your information, you can look up the language of, or the notation for regular expressions for pattern on, for instance, on Web Consortium Schools, so Web Schools. I think it's run by Web Consortium. It's a pretty famous page where you can find a lot of digestible information on different technologies that make up internet. And on XSD restrictions, well, just Google it up or have a look at the address here. And then you see the actual examples for XSD, which is not really relevant because XSD itself is hidden from you in Quasar. So you don't really need to know XSD to profit from all those mechanisms. But then what is interesting for you should be something like patterns. And I think exactly it's here. So here you can find a couple of examples and also information on how you can actually write your patterns. Okay, I think this example is pretty understandable. Anyway, so let's give it a try. So I changed my design, so I have to rebuild the server. Okay, so the server is built, and now let's give it a try. So I'm refreshing the dependencies. I'm reloading the dependency for Eclipse, and now you remember I added this, I think, per controller config entry, like the most typical one, propagates into an attribute. So I'm adding this attribute address. And then let's now put something which I thought would be valid. So like USB 2, I'm saving my config file and I'm trying to run my server. So what happens is this seems to be just fine. But then if I, I use something that clearly does not match the pattern, what happens is, well, the server will not start and the configuration file will be revoked. And again, I would like to remind you that this is a pretty standardized mechanism. And for instance, you can use a very common tool called XML-lint to actually validate your configuration schema. To validate your configuration against configuration schema. Alrighty. So, we had a look at 3 possible restrictions that you can attach per configuration entries and cache variables, and now a bit more on other type of restrictions. So the last one which I'd like to show today is when you relate a class to another class, and I'm specifically speaking of has objects. So the last restriction that I'd like to demonstrate today is relates to has objects. So no longer on particular data, but rather on a relation between classes. So perhaps you remember that why we see that a controller is a parent of motor is because when we go to the controller, we find has objects, right? And then the has objects tells us that a motor or motors, but motor as a class is a child of a controller class, like in the sense of Quasar classes. But we said that conceptually, in the technical sense, the controller can support up to 4 motors. So, let's put this limitation right now. So let's put that restriction. So whenever you see has objects, you find in attributes that you can also say what is the cardinality here. So I will add actually both of them, and the defaults are, as you say, like from essentially unlimited. This is actually the biggest possible integer number, unsigned integer on 32 bits, I think. But I say I'd like from 0 to 4, right? We said up to 4, and we give the client, the end user, not the client in the sense of OPC-UA client, by the person configuring or using a server, we give them a chance to deploy from 0 to 4 motors per controller, right? So now I added this restriction, and you can say actually it quickly propagates into design diagram. So obviously you can use it everywhere else. For instance, you can limit your server to support up to 1 controller, right? So this you can do from root has objects. But there's one more interesting case here. It's very practical. Namely, what happens when you say that there has to be strictly 1 object? And I'll do that for the airflow probe, motor airflow probe. Okay. So I go to my motor class, and then I find the has objects for airflow probe. Okay, this one. And then I say add attribute minimum and add attribute maximum, and that will be from 1 to 1, which simply says simply 1, which means that Quasar will make sure, will guarantee that whenever the server runs, there's always one airflow probe in the system, like one object per every motor. Okay, this is how you read this, which has a nice consequence. So the nice consequence of having precisely one object per class is that when you write your device logic, and that would be actually, before I do that, let me show you. So we go into build and then device, and inside generated you find things called base classes. We don't have to explain what they do, but this is what your actual device class will inherit from. So there's a lot of nice magic there, which is hidden from you on purpose. But what you will find there, and I'm just trying to find this thing, is now look. You remember that you can browse the device collection by giving the name of a class in a plural, so like airflow probes. But now, since your hash objects links to exactly one object, as you see in the comment, you have now airflow probe, just that. And that is, as you remember, guaranteed by Quasar now, that there will be precisely one object per class, which means you can safely write code like this. You just do airflow probe, and voila. Okay, here Eclipse is not really. I think it didn't load my class, but anyway, it's entirely safe to do that. That will retain you precisely one pointer to this one object that is per motor. So you don't have to do air probes, check the collection size. If it's actually more than one, then access that and do something. No, it becomes much more simple. All right. So in this chapter, we talked a bit on XML, on config restrictions that Quasar supports. So we've went through restriction by enumeration, restriction by pattern, and restriction by bound, and then we also had a look how to restrict a number of objects per parent object. We also looked at those singleton objects, so like precisely one object per parent object. So the advantages for this, as you remember, are that this is a standardized mechanism that propagates into XSD. XSD is standardized, so it can be also used for integrating your OPC-UA server with other parts of your software ecosystem. And it minimizes your work because you can add the restrictions, and it's actually the XML loader which will guarantee that the configuration is in the right schema. And so there's less work for you to be done. So I hope that you'll have a ample use of config restriction whenever you can use them. I think it's a good practice to restrict everything that can be restricted, because this actually gives you more static, more stable system. Not that I'm a fan of static things, but in high reliability software projects, like things that you do for control systems, for which Quasar was actually conceived, this is a very attractive feature. So thank you. That was part 9, and I hope to see you in the next part.